Good morning, students. Excuse me. We're going to be working on solving systems of equations by a new method called addition. Sometimes this method, depending, on your high school textbook, might have been called elimination as well. And you may hear me use the word eliminate or eliminating as we go along. So we're going to work on this method and we're going to show how it gives results. Okay, here we go. Let's get started. So here's a problem. The fundamental challenge with the addition method is you want to add the equations together. And in the process, you actually want to eliminate a variable. What this is called is linear operations, and these are legal strategies to manipulate mathematics. You can actually add equations together. We've been adding to both sides of an equation, but you could actually take two equations and add them together. But you want that addition of equations to actually accomplish a purpose. And what we want it to do is we want it to eliminate a variable. So here's a first simple example. If you look at these two equations and you add them together, notice the 5x plus the negative 5x is 0. They eliminate the variable x. The negative y plus the 2y is y, and the 14 plus the negative 13 is 1. So we have now found out that y equals 1. Once we know that, we can proceed like we did with the substitution method. We take 5x minus 1 equals 14, grab one of the equations, and solve that equation, or not 5x, and solve that equation for the remaining variable. So we now get 5x equals 14 plus 1. We're adding 1 to both sides, so that's 15. Then we divide by 5. So we end up with x equals 3. So our answer is the ordered pair 3, 1. And we want to check it in the other equation. So negative 5 times 3 plus 2 times 1 is negative 15 plus 2, which is negative 13. So it checks. So I know that I've done it correctly. Okay? So remember, when we solve these equations, we don't just say x equals y equals. The answer is written as an ordered pair, and then always check your answers, okay? And I'm going to give you some more information, another way to check here in a little bit. Now, let's do some that are a little more difficult. Notice, just before we go on, that this equation already had things we could add together and eliminate a variable. But what do you do if they don't? Let's try that. Okay, here's a new equation. Now, when we look at this one, we see we have a 2x and a negative 3y in the first equation, a negative 6x and a 12y in the second equation. So what we want to do here is we want to get rid of one of the variables. So let's say we want to get rid of y, okay? Let's just say we want to get rid of the y. Then what we need to do is we need to make them have the same coefficient. So what we're going to do is we're going to multiply this equation by 4. Now, why do I multiply by 4? Because 4 times negative 3 is negative 12. And then that will add with positive 12 to give 0. In other words, it will eliminate the y variables. So your goal is to have coefficients have the same magnitude, but different signs. That's the goal. And basically you look for least common multiples. And so since this is a negative 3y, and this is a positive 12y, I already have opposite signs. So if I multiply one of the equations by 4, then, or this equation by 4, then I'll get a negative 12y and I can eliminate. So what I do, this is really step 1, where we figure out what to multiply by the equations. And then we do that, so we rewrite the system 8x minus 12y equals negative 16. And then I have the negative 6x plus 12y equals 6. And now then we can eliminate a variable by adding the equations together. 8x plus a negative 6x is 2x. Negative 12y plus 12y is 0, and negative 16 plus 6 is negative 10. And then we divide both sides by 2, and we get x equals negative 5. So once x is equal to negative 5, we can go to step 2, and we substitute in one of the equations. So 2 times negative 5 minus 3y equals negative 4. So that's negative 10 minus 3y equals negative 4, which is, I add 10 to both sides. I get negative 3y equals 6. And then I divide both sides by negative 3. And I get y equals negative 2. And so my solution is negative 5 for x, negative 2 for y. That's my answer. And so what I want to do then is I want to check it in the other equation. So the other equation is negative 6 times negative 5 plus 12 times negative 2. Is that equal to 6? And so this is 30, negative times a negative 30, plus a negative 24, which is equal to 6. So it checks. So I now know I've done it correct. All right? Now, there is another way you could check, and just for fun, you could graph it. And so let's just do that briefly. Here's the graphing calculator, and let me move it over just a little so I can see the equations. All right. And so the first equation, well, let me, there we go, shrink it just a bit. Okay. And so now I can type, I can't type the equations, I'm sorry. Give me a sec. Okay, I apologize, had some issues there setting that up. Anyway, here's the graphics calculator, and as you see, I've typed in my system, and here are the graphs. So this is what I would do on the first lesson in this chapter, is we would solve by graphing. But notice how it gives me a great way to check, and I see that I still get the same answer, negative 5, negative 2. So this is another way to check to make sure I've done the algebra correctly. You can just use graphing. Now, evaluating to check and using graphing to check are very powerful tools to make sure you're doing algebra correctly. And I recommend you use both of them, kind of switch off so that it becomes a normal, constant habit that you check your answers by graphing. I'll be showing you how to check with graphing and evaluation all through the rest of this semester. Okay? So I'm comfortable I have done this correctly. I'm good. If I made a negative sign mistake, then I'd find it. Let's do one more. Okay, this problem, 2x plus 4y equals 5, 3x plus 6y equals 6, when we look at it, I can't just multiply one equation to get the number. What you have to do here is you multiply both equations to get like a least common multiple. So for instance, let's eliminate the x. So I'm going to multiply this equation by 3, and it will become 6x plus 12y equals 15. And then the next equation I'm going to multiply by negative 2, which will give me negative 6x minus 12y equals negative 12. And so when you look at these right here, you can see that the x's will disappear. And that's what you want to happen. And so sometimes you may need to do that. But notice the goal is always same magnitude, opposite signs. I could have done negative 3 and positive 2, and that would have worked as well. Okay? Now, something else happens on this equation. 6x minus 6x is 0. 12y minus 12y is also 0. So we get 0 equals 15 plus negative 12, which is 3. That is a false statement. Therefore, there is no solution to this system of equations. So that can happen as well. Even though you do all this multiplying, you could end up with a particular problem that leads to a false statement or no solution. So this is very much the same that we encountered. All this means is that these particular lines have the same slope, and therefore they were actually parallel. Okay? And so that means they have no solution. And if you want to check that, go ahead and graph them, and you'll see that you have parallel lines. Okay? So this is also a very typical occurrence. Now remember, if you get one that says 3 equals 3 or 0 equals 0, then it's a true statement, and then it has infinite solutions. Okay? And so we went over this with substitution method and graphing methods. And so the same things hold true in this case. All right? Finally, let's do one more that's just like super complicated and just show you how you can work through it and make it simple. So here's a complicated one. This is a equation. We want to use the addition method. That's what they tell us to use. But it's not in a nice format. Normally we have like some x plus y equals a number, and it's not in that standard form. So what you have to do is put it in standard form first. So I take the first equation, 2 times x plus y equals 4x plus 1, and I multiply by the distributive law. 2x plus 2y equals 4x plus 1. And then I subtract the 4x, and I end up with negative 2x plus 2y equals 1. So now it's in the format that I saw on all the other ones I did before. I do the same thing for this equation. 3x minus 3y equals x plus y minus 3. So I'm going to subtract x from both sides. I'm going to subtract y from both sides, and I end up with 2x minus 4y equals negative 3. So there's my equation. So if I put them together, negative 2x plus 2y equals 1, and 2x minus 4y equals negative 3, I can do the addition method because right away I see these two will add to 0. So I don't even need to multiply. So I automatically get negative 2y equals negative 2, so that when I divide by negative 2, y equals 1. And if y equals 1, I can use one of the equations, negative 2x plus 2 times 1 equals 1. So negative 2x plus 2 equals 1. And I subtract 2 from both sides and get negative 2x equals negative 1. Divide by negative 2, and I get x equals 1/2. And so my solution is 1/2, 1. And I'm going to leave it to you to check this one on your own. All you need to do is either graph both lines. You can graph them here, or you can put the original equations. Either one's okay. And then check the point where they cross, or you can just plug this in to these equations, and this is an easy plug-in even though you have a fraction, because 2 times a fraction or a 1/2 is pretty easy to figure out, so it's not too bad. So I'll let you check this on your own. All right. Okay. Let's do one more special case. You want to do another special case? Another special case you might encounter could be something like this, where you get like x over 2 equals y plus 8 over 3, and x plus 2 over 2 equals y plus 11 over 3. So in this case, there are fractions. And so what we want to do is we want to get rid of the fractions first. So what's the common denominator? It's 6 in both cases, so I'm going to multiply by 6. And what's that become? This will become 6 times x over 2 equals 6 times y plus 8 over 3. So there's that first one. And 6 over 2 is 3x. And then 6 over 3 is 2, so you get 2 times y plus 8. And then that becomes 3x equals 2y plus 16. And then you subtract the 2y from both sides. And now this is in the form that you want. 3x minus 2y is 16. Now we can do the addition method and for that equation, but we got to finish this one first now too. So let's rewrite it. So it's 6 times x plus 2 times the whole denominator over 2 equals 6 times y plus 11 over 3. And 6 over 2 is 3, so you get 3 times x plus 2. And 6 over 3 is 2, 2 times y plus 11. And so that's 3x plus 6 equals 2y plus 22. All right. And so then we want to subtract 6 from both sides, and then subtract 2y from both sides. And so we end up with 3x minus 2y equals 16. And there is the second equation. And so it turns out in this case that they're both the same. So when you do the addition method, you can multiply the second one by -1, which changes the signs. And when you add them together, you get 0 equals 0, which means you have infinite solutions. And if you have infinite solutions, then that means you say the answer is the set of all ordered pairs x and y such that what? 3x minus 2y equals 16. You just pick one of the equations that you use to solve. Now, if you wanted, you could pick one of these original equations and actually write it in this spot as well, and that would be correct too. So, either case, all right? And remember, this is how we write an infinite solutions answer. We don't just say infinite solutions. We say what the ordered pairs have to look like. Okay, that should be it on solving by the addition method. All righty, talk to you later. Bye.